Welcome students. I hope all are fine. In the previous week actually your pre-annual test is completed. Okay, so now today we actually discuss about our chapter number 7, that is sound. Okay, so before discussing the whole chapter, actually we have to know about what are the key concepts or key points that actually we know in this chapter. That is, first is the key points. Key points we can say, first one, A is what is sound. At first we have to know actually the definition of sound, and the second one, that is propagation of sound. Propagation of sound. And the next one is actually terms related to sound propagation. Terms related to sound propagation or related to sound wave. And the next one is actually characteristics of sound. Characteristics of sound. Here actually we discuss three characteristics. That is actually, first one is loudness of sound, or we can say actually intensity of a sound. The next one is pitch of a sound. And the last one is actually quality of sound. Or we can say timbre. Okay, quality, or it's called also timbre. And here also loudness or intensity, we can say this is intensity of sound. And also know about our point number 4, that is actually, that is we can say music and noise. What do we mean by music or noise? Okay, music and noise also. And the next one is some musical instruments. Okay, some musical instrument. And also know about monotone. Okay, and the last one, that is actually we have to know, that is units of loudness in decibels. Okay, units of loudness or intensity. Okay, loudness or intensity of sound in decibels. Okay, in decibels. Now here actually in this class we actually discuss, that is we actually discuss here the first three portion or first 3 point, we can say A, B, C. Today actually we discuss these 3 points. Okay, first one is what is sound actually. So first one, we take the first point, that is what is sound. Actually sound is a form of energy, we can say, that actually help us to hear, okay, in our ear. Okay, in generally, from which object sound actually produce? From a vibrating body. Okay, we can say from a vibrating body sound is produced, and we can easily hear the sound. Okay, and this is a, also we can say this is a form of energy. Okay, form of energy that helps us. Okay, that helps us to hear. Okay, now the question is, always actually sound is produced? Yes, actually from a vibrating body Okay, sound is always produced, but sometimes we can hear, sometimes we can't, because of its frequency. Okay, in the later actually we discuss what is a frequency actually. Okay, so now actually just remember that what is sound. Sound is a form of energy that helps us to hear, and it is always produced from a vibrating body or vibrating object. Okay, that may be living or non-living also. Okay, and we can hear different types of sound. Okay, because their frequency is different. Okay, so that is why actually we can hear different types of sound, and we also discuss what is frequency in the later. Okay, now the next point, that is actually the next point is propagation of sound. Okay, how actually sound is propagated. Okay, or we can say propagation of sound. In generally actually sound is propagated in the form of a wave. Okay, and this type of wave cannot travel through vacuum. Okay, actually sound is propagated through any medium. Okay, and here actually the process propagation of sound in the form of, actually this is occurred in the form of, we can say in the form of compression and rarefaction. Compression and rarefaction. In generally we can say that sound is propagated in the form of compression and rarefaction, and also we can say sound cannot propagate through vacuum medium. Okay, that is why actually sound is called also, this is called also mechanical wave. Okay, so for mechanical wave actually a medium is required to propagation. Okay, or to propagate any type of mechanical wave a medium is required always. And here we can say that the speed of sound actually approximately we can say 330 or 340, or we can say that is 340. Okay, 340 meter per second in room temperature, or we can say at 20 degrees Celsius. Okay, in generally actually the speed of sound is vary with temperature also. So in generally we take the speed of sound 340 meter per second in 20 degrees Celsius. Okay, and also the speed of sound is different in different medium, such as suppose we take solid. Okay, suppose we take solid medium, and another medium is liquid, and another medium is, we can say, suppose gas. Here we can say the speed of sound is the most in solid medium. So we can say velocity in a solid medium is the most, then greater than actually velocity of liquid, and then velocity of gas also. So here actually speed of sound in gaseous medium is the least, and velocity of sound in solid medium is the highest or the most value. Okay, so this is the propagation. Okay, from this case actually we have to know that without any medium sound cannot propagate. Okay, now we move to our next point, that is actually different terms, that is terms related to sound. Okay, actually terms related to sound. Here actually we discuss about five different terms, that is suppose first one is, we can say actually wavelength. Okay, so what is actually wavelength, or what is the definition of wavelength? We already discussed that sound is propagated through any medium, or through suppose air medium, in the form of generally compression and rarefaction, in the form of wave also. So now the question is, what is wavelength? Okay, in generally what is wavelength? Actually it is the distance between to consecutive compression or rarefaction. Okay, so we can say that this distance is generally same as the distance between two successive crest or trap also, and it is generally defined as actually with the symbol that is lambda, and this is Greek letter, and also the unit of wavelength because is meter actually in SI system, because actually wavelength is the distance, so simply we can take meter and centimeter in CGS system. So this is the definition of wavelength. In generally the distance between two consecutive compression or rarefactions, or we can say the distance is the same as the distance between two successive crest and trough. And next, actually the next point, that is amplitude. Okay, so second option is amplitude. Here we can say what is amplitude. In generally, amplitude is the maximum displacement of a wave on either side of its mean position is called actually amplitude. It is also a distance, so we can take as meter and centimeter also, m and cm, m in SI and cm in CGS system. It is also a displacement, that means the distance. Okay, so what is the definition? The definition is the maximum displacement of a wave on either side of its mean position is known as amplitude. Now we move to our next point, that is we take as, suppose we take the third one, that is the, we can say, oscillation. What is actually oscillation? Okay, here we have to know about what is the definition of oscillation. In generally, one complete to and fro motion of an object or particle about its mean position is called one complete vibrating actually cycle, or one oscillation. That means suppose we take one pendulum like that, and pendulum just covered the distance. Suppose it travels from a point, that is the mean position, and travel the extreme point B, and from B the pendulum comes back at A and travel to point C, that is the left extreme point, and after covering the distance actually again the pendulum come to its original position, that is A. So here actually the pendulum completes one to and fro motion. So this motion is called one oscillation. Okay, so this is the actually definition of oscillation, we can say. So one body or one particle when complete to and fro motion of an object about its mean position is known as one complete vibrating cycle or one oscillation. Now we move to our next point or next term, that is actually time period. Okay, and in generally time period is expressed actually with the letter that is capital T. It is generally denoted by capital T. And what is the definition? Definition is time period of a wave is the time taken by it to complete one oscillation. Okay, so it is the time to complete one oscillation by any vibrating object or vibrating body. That means it is the time, so its unit as a unit is just second, we can say. Its unit is second. Okay, and the next one, that is 0.5, we can take 5, that is actually frequency. Okay, so what is frequency? In generally, frequency, that is in generally defined or is denoted by small f. This is the term small f, and frequency of a wave is the number of oscillation completed by it in 1 second. Okay, so total number of oscillations completed by a vibrating body in 1 second is called frequency. It is generally denoted by small f, and in generally we can say that frequency is equal to 1 upon time period t. And from this relation we can say the unit of frequency is second inverse, or this is called hertz. Okay, so this is the unit of actually frequency. So these are the terms, that is 5 terms that is related to sound. One is wavelength, and second one amplitude, third one oscillations, and fourth one time period, and also fifth one that is frequency. Now if we take a image like that, or take an image of wave, okay, just like that we draw, this is the wave, okay, and here we can say this is the second part. Okay, so here actually the positions are, we take a different position. Suppose this point is say P. Okay, so this is your P point, this is Q, this is R, and this is your S. Okay, and this is actually in x-axis we take distance, and or we can say traveling distance by a sound, and this is the in y-axis the displacement of actually particles. Now here actually the maximum displacement, that is here from this figure we can take the crest. Okay, so here actually this is the maximum displacement, that is AB we can say, or we can say this is the maximum displacement CD also, and this is actually the trough point. Okay, so this is your final trough, the point of maximum rarefaction, or this is the crest point, or we can say this is your crest and the point of maximum compression. Here actually we can easily see here AB, or we can say CD, that is actually amplitude. Simply we can say this is amplitude, okay, of the body. And in generally here actually one oscillation means P to R. Okay, so P to Q, Q to R, that is actually one oscillation, and one oscillation, and the time period, that is the time taken to complete one oscillation, that means P to R. Okay, to complete the oscillation P to R, the time taken is called actually time period, and the inverse of time period is called frequency. And here also what is wavelength? Actually wavelength is the distance between two crest and two trough, or we can say, so here actually AB is the first crest suppose we take, and this one is the next one, that is suppose A dash and B dash we take. So here actually the distance that is BB dash, it is the distance between two crest point, so we take this is your actually wavelength. Or we can say from this case also P to R, because P to R is one oscillation, this is the distance covered by one oscillation, that is also called wavelength. So we can say also PR, that is actually wavelength. Okay, so these are the terms that is related to a sound wave. Okay, and we have to know about the terms very carefully, and in the later actually we can find out. Suppose here we can see, we know what is speed of light. In generally speed means actually a distance or displacement covered by wave in unit time. That means suppose we take velocity of speed as v. So that means actually we can say actually displacement of particles, okay, displacement, maximum displacement of particles, okay, divided upon actually time. Now actually if we take one complete uh, actually wave, then actually what is the maximum distance, that is called actually wavelength, okay. So we can say here also actually we can say distance covered by one wave, okay. So here we can write also distance covered by one wave or one oscillation upon time period. So in this case we take actually this is lambda divided by t, and we also know 1 by t means actually frequency, so this is f into lambda. So v is equal to f lambda. This is the relation between speed of sound with frequency and wavelength of a sound, okay. So here actually v means speed of sound, that is in unit meter per second, here frequency in hertz, okay, there is a unit of frequency is hertz, and lambda that is actually meter. In this way we can find out the relation between velocity, frequency and also wavelength of a sound, okay. So actually this is the end of today's class, okay. In the next class we actually discuss about loudness or intensity, quality and also pitch of a sound, okay.